Hi, to begin with, we have chosen methanol as a compound for presentation.
This is the group member involved in this presentation.
Introduction to methanol.
Methanol, also known as methyl alcohol or wood spirit. Here is the structural formula for methanol. The chemical formula for methanol is CH3OH. The functional group for methanol is alcohol, and it is a primary alcohol as the hydroxyl group is connected to a single carbon which is not attached to any other carbon atom and only hydrogen atoms. This makes methanol the simplest example of a primary alcohol. Methanol is a colorless liquid with a slightly alcoholic similar to ethanol. The boiling point for methanol is 64.7 degrees Celsius and melting point at negative 97.6 degrees Celsius. Methanol is completely miscible in water and highly flammable, burns with a bluish flame. The reactivity of methanol is it can undergo various chemical reactions, including oxidation to form formaldehyde and formic acid. It can also react with halogens to produce alkyl halide. The toxicity of methanol is extremely hazardous substance that poses serious health risks, including blindness, kidney damage, and even fatal consequence. Proper handling and strict precautions are necessary to prevent exposure. Up next, my friend will explain about the application of methanol in industry. Let's go.
So, today I'll be talking about methanol and the many ways it's used in everyday life and industry. Methanol is a simple alcohol, but it's extremely useful in many different fields because of its chemical properties. One of the most important industrial uses of methanol is in the production of formaldehyde. Formaldehyde is a chemical that's used to make many everyday products like plastic, plywood, resins, paints, adhesives, and even more some fabric. In industry, methanol is converted into formaldehyde through a process called catalytic oxidation. In this reaction, methanol reacts with oxygen gas at high temperatures, usually between 250 and 400 degrees Celsius, which is using a metal catalyst like silver or metal oxide. The reaction looks like this. CH3OH plus with half of O2 becomes CH2O and H2O, or simply put, methanol and oxygen react to form formaldehyde and water. There are three main reasons why methanol is good choice for this process. For the first, methanol is highly reactive, which means it easily reacts with oxygen to form formaldehyde. Second, it has a low boiling point, so it can easily be turned into gas for high temperature reaction. And third, methanol is cheap and widely available, which makes it cost-effective options for large-scale production. Today, about 60% of all formaldehyde made in the world starts from methanol. This shows how important methanol is in the chemical industry, not just a substance on its own, but as a building block for making many other useful products. So, I will pass to my other team members to explain more about the chemical reaction of methanol. So, let's go!
Hi everyone, today I will be discussing two fundamental organic reactions involving alcohol, which is oxidation and esterification. Let us begin with oxidation. Primary alcohol can be selectively oxidized to aldehyde using PCC or pyridinium chlorochromate in dichloromethyl. This reaction is useful when full oxidation to a carboxylic acid is not desired. However, if further oxidation is needed, strong oxidizing agents such as potassium permanganate or potassium dichromate in acidic condition can be used. This reagent oxidizes the primary alcohol all the way to a carboxylic acid. Now, moving on to the esterification. This is a condensation reaction between a carboxylic acid and an alcohol, typically conducted under reflux condition. The reaction produces an ester and water, and is catalyzed by a strong acid, most commonly concentrated sulfuric acid. The sulfuric acid acts as both as a catalyst and a dehydrating agent to drive the equilibrium toward ester formation. This slide demonstrates the oxidation of methanol, a primary alcohol, using PCC in CH2Cl2. Here, methanol is oxidized to methanol, more commonly known as formaldehyde. PCC is chosen here specifically because it enables controlled oxidation. It also converts the alcohol to the aldehyde without over-oxidizing it to a carboxylic acid. This reaction highlights the importance of reagent selection in organic synthesis, especially when targeting specific oxidation states of carbon. In this slide, we see a classic esterification reaction. Methanol reacts with propanol acid in the presence of concentrated H2SO4, which serves as both a proton catalyst and dehydrating agent. The result is the formation of methyl propanoate and water. This reaction is carried out under reflux condition to ensure sufficient energy input and to prevent the loss of volatile reactant. Esterification reactions are widely used in the fragrance and pharmaceutical industry due to the desirable aromatic properties of ester.
This is the link that we refer to do our presentation.